All right, so picking up on number 14, we're going to continue with how to do the naming going both directions, writing formulas from names and writing names from formulas. So silicon dioxide. So remember, whenever we see monoditri, we're dealing with a molecule, something that's been covalently bonded. All right, so we just do what it tells us, silicon. So there's one of them. Dioxide, di means two, so O2. Silicon dioxide, we're done. Okay, and as in the previous video, like I said, I'm not going to make all of these subscripts how they're supposed to look, just for time. All right, so carbon tetrachloride, same thing. We see a mono, di, tri, tetra, so we're going to do it just what it says. Carbon and tetra means four, so tetrachloride, carbon tetrachloride. Okay, our next one here, we have Ni3PO4 parentheses 2. Well, we're dealing with a polyatomic because we see more than two capital letters, but also PO4 we see it's in parentheses. So we name the first substance, nickel, okay? And then I'm gonna give some space, phosphate. Now, if you notice in your periodic table, nickel has more than one option. It's a positive 2 or positive 3 cation. So he has two ways he could be. So here's what we do. We look at the guy not in question. So on your table, PO4 is a negative 3. Okay, there's two ways you can figure out what nickel was. You can take 3 times 2 and get negative 6. Then if there's 6 electrons being taken, there needs to be 6 given. So 6 divided by 3 would tell me nickel, Roman numeral 2, phosphate. Okay, now that's one way you could do this one, and that would work. This is also one that you could drop and switch. If the negative 3 charge, which I'm not writing, but it's right here, the negative 3 charge on phosphate is here. Notice there's a 3 down here. The 3 came from phosphate, the 2 came from nickel. Okay, so when you're looking for your Roman numerals, what I would do if you have not done this yet is on your periodic table, any one of them that has more than one option, so like vanadium, chromium, manganese, iron, cobalt, nickel, copper, I would highlight them so you know every time you see those, you will be doing Roman numerals. Okay, next one. Manganese fluoride, so same thing. Manganese is a transition metal. He's got 2, 3, 4, 6, 7 are his options. Okay, so I'm going to name the first substance. Manganese, fluoride. Okay, second substance, fluorine becomes ide. Now, fluorine's a negative 1. He's a halogen, he's going to take 1. So if he has 1 being taken, and that happens 4 times, there's 4 electrons being taken. That means manganese gave 4. So Roman numeral IV for manganese for fluoride. All right, our next one here on number 18, we've got arsenic and we have oxygen. So we have 2 substances that are going to be sharing. They're both on the right of the stair step. So this is when you use your monoditri. So there's 2 arsenic. So 2 arsenic. Now there's 5 oxygens, so the oxygen becomes pentoxide. All right, number 19, we notice that we have H, so we're dealing with an acid, and we have an oxyacid. We've got oxygen in it, we have a polyatomic, so we don't use hydro on this acid. Hydro is only when there are 2 substances, when it's binary. Okay, so we look up what the polyatomic is. Polyatomic is phosphate, so phosphate goes to ic, so this becomes phosphoric acid. Number 20. Okay, iron is a metal. He's got 2 options, 3 and 2. So we know we're looking for a Roman numeral here. So I name the first substance, iron. Second substance is iodide. Now, if iodine is a negative 1, I find that by looking on the periodic table. He's in family 17, 7 valence electrons. He's going to take 1. If he's taking 1 that happens twice, that means iron gave 2. So iron, Roman numeral 2, iodide. Number 21. Phosphorus and sulfur coming together. So phosphorus is a nonmetal, sulfur is a nonmetal. So this is molecular, so you use your monoditri. So we've got 4 phosphorus, so tetraphosphorus, and then there's 3 sulfurs, so trisulfide. Oops, sorry. Okay. Number 22, we have hydrofluoric acid. So whenever you see the hydro, you know it's just 2 substances. So it's hydrogen, oops, and it's fluorine. The ic goes to the fluorine, all right? And fluorine's a negative 1. Family 17, 7 valence electrons, takes 1. So H and F just come together, HF for hydrofluoric acid. So you should see a trend, like hydrochloric acid will just be HCl, hydrobromic, HBr, everything in the halogens, it's just going to be H in the element, okay? And then if you're going to family 16, hydrogen coming with sulfur is just H2S. It's, it's how many they come together, but that's the acid. All right, 23, selenium and oxygen. Selenium is to the right of the stair-step line, so we're going to use the monoditri. So you name the first substance, selenium, and there's 2 oxygens, so dioxide. Next one on 24, silicon. We're looking at a covalently bonded substance, okay? 2 on the right of the stair-step line. So name the first one, silicon, and there's 4 iodines, so tetraiodide. Oops. All right, number 25, sulfuric acid. So notice there's no hydro in front of it, so we're dealing with an oxyacid. So ic goes to 8. All right, so sulfuric is actually sulfate. So hydrogen's a positive 1. SO4 is a negative 2. So there's 1 here, 2 being taken. That means I need 2 hydrogens to match up. H2SO4 is sulfuric acid. Number 26, barium is a metal, so we're going to name this ionically. So barium's the first substance. OH is hydroxide. Find that on the polyatomics on the bottom of your periodic table. Nobody requires Roman numerals. You're done. Coming down to number 27. Name your first substance. It's a metal, so it's copper. Okay. Second substance is sulfur, so the sulfur becomes sulfide. Now, copper does require Roman numeral. If you look on its periodic table, it's 2 and it's 1. So if sulfur, this one's a little bit tricky, I will write this one here. If sulfur is a negative 2, family 16, 6 valence electrons, going to take 2 to get to 8. If he took 2, notice it's just CUS, that means copper had to give 2 for the 2 of them to be balanced out. All right, so you have to look at the charge of the guy not in question. Don't assume this is copper 1 just because there's 1 of each. You got to look at the charge of the guy that's not in question and then determine what it is. All right, number 28, we've got 2 nonmetals here, so we'll follow our nonmetal naming rules. So there's 4 phosphorus, so tetraphosphorus, and there's 10 oxygen, so 10 is deca, so it becomes decoxide. All right, number 29, phosphorus trichloride. Same thing, you're dealing with 2 nonmetals, plus you see the monoditri, so you know you're going to just do what it tells you. So phosphorus trichloride, whoops, little l. Okay. Ammonium phosphate. Ammonium is a polyatomic. This is not ammonia, this is ammonium. And ammonium is NH4, and the charge on that's positive 1. Phosphate's a polyatomic, PO4, and its charge is a negative 3. So if I have 1 being given, 3 being taken, I need 3 of the guy giving 1. So I'm going to go NH4 in parentheses, 3, PO4. Okay. All right, almost done here, guys. Iron 3 sulfate. So you see the Roman numeral that's telling you iron's giving 3. Sulfate is SO4, he's a negative 2. So the closest way these guys can combine is 6. So to get to 6 electrons, iron is going to have to give 2, or he's going to have 2 of them, giving 3. And SO4, you're going to need 3. You need 3 of that whole thing. So 2 times 3 is 6, positive 6 giving. 2 times 3 is negative 6 taking. And so we're balanced. Fe2, SO4, parentheses 3. Number 32, nitrogen monoxide. So you just do what it tells you. Nitrogen, 1 oxygen. No. Okay. Number 33, dinitrogen tetroxide. So once again, do what it tells you. So dinitrogen, there's 2 of them. Tetroxide means there's O4. Number 34, aluminum is a positive 3. Carbonate is a negative 2. Just like we did up here with iron 3 sulfate, 3 and 2, we got to get them to 6. So there's going to be 2 aluminums. CO3, you're going to need 3 of them to match up. Number 35, sulfur dioxide. Do what it tells you. Sulfur, and there's 2 oxygen. 36, do what it tells you. Carbon tetrachloride. CCl4. Okay, because it says there's tetrachloride. All right, and 37, our very last problem here, we've made it plutonium 6. So Pu is a positive 6, pyrophosphate is P2O7, and he's a negative 4. Closest number these two have in common is 12. So to get to 12 on the plutonium, it's going to be Pu2, P2O7, oops, I'll move it so you guys can see, P2O7, and to get to 12 here, I need 3. Okay, so we take a look. 2 times 6 is 12, so there's 12 electrons being given. 3 times negative 4 is negative 12. That's 12 electrons being taken. We're balanced. Pu2, I'll make it look right for the very last one. P2O7 and 3 on the subscript. Okay, this is writing formulas from names. This is naming from formulas. This is all level 4, okay? Make sure that when you take this assessment on Wednesday that you're looking, first of all, am I dealing with a metal? If so, I'm looking at possible Roman numerals. Am I dealing with hydrogen? If so, it's an acid. If I am dealing with 2 things to the right of the stair-step line or directly touching on the stair-step line, then I'm probably going to be dealing with naming with the mono ditri. Okay? If you have more questions, you guys know how to get a hold of me. Tweet me, text me, email me, and I can give you some more problems if you need them. You're going to assess on Wednesday morning. I will not be here in the morning classes. We're going to assess to see where you're at. So some of you guys are going to be able to continue to move on with molecular shapes, and some of you, we got to make sure we get this naming thing under control. All right? Good luck, guys.